Hi, welcome back to the Cuzzy Sound channel and part 31 in the series all about my Project 12 DIY modular analog synth. In this video we'll be looking at my latest module, which is the Barton Musical Circuits 4046 Wave Shaper. What I'm going to do is have a look at what the circuit is, have a look at how I put it together, and then we'll have a look at it in the Project 12 synth and have a listen to some of the things that it can do. So we'll start by going over to the computer and having a look at the Barton Musical Circuits website and then how I interpreted that into my own build. This is the Barton Musical Circuits website. I'll put the link to the website down in the description for my video. There's lots to kind of look at here. What we're interested in is the DIY section. There's filters for picking out files because there's loads. We're interested in analog circuits, and as I say, there's loads. That's just the analog circuits. This one that's highlighted, 4046 Shaper, because I've been here before, because that's what we're building. So this is what the web page that looks like. There's a very brief description of what it is. There's a little bit of a demo on a video there. One of the things to note, if you don't like strip boards and you prefer PCBs, it looks like you can actually buy a PCB for $8, which is not a lot really, and unfinished Eurorack panels which are 12 HP and cost $8. I've not tried buying anything because A, I don't do Eurorack, and B, I don't really do PCBs. What I do is strip boards, which we'll see in a moment. What there is though is a PDF file which you could download, which is the documentation for this particular project. There's a brief description of what the module does, what the controls are. There's a couple of sound demos you can click on. Here's the interesting bit for me. It's the schematic for the circuit. So there's the 4046 oscillator and a 4040 binary counter, and then there's input and output conditioning done with a simple op amp. TL072 does the job nicely. The interesting bit is how we get to have the output signal the same frequency as the input, but then not only can we divide by 2, divide by 4, divide by 8, which I've done with binary counters before, but it's wired up in such a way that we also get multiply by 2, multiply by 4, and multiply by 8. The way that happens is the fourth output of the 4040, which toggles every 8 inputs, is then sent back to the comparator input of the 4046, which tricks the 4046 into thinking its frequency is 8 times too low and adjusts it until it's in phase with the divided version of its output. Hence the name phase lock loop oscillator. If you want more detailed description about the circuit, then have a look in here, but basically it just means that we can get multiples and divisions of our input signal. All the outputs are going to be square waves because it's coming from a binary circuit. There's the parts list, there's PCB layout, that's what his version looks like. So yeah, lots of really useful information. But as I say, I'm actually using strip board layout. Now actually, if I go back, there is on the circuit diagram there's a switch section here, and this is a filter on the output, which on the oscillator, which you can switch in and out combinations of capacitors, which actually changes the slew rate between note changes. I've missed that bit out because my panels are, well, the one I've chose to use is a bit, as you can see, is a bit small, and I was worried I wouldn't have space. So that's not on my strip board layout. It would be in this area here. Right, okay, so there's your 3 chips, your oscillator, binary counter, and your op amp. This is what one of the inputs to the mixer section would look like. Basically you want 7 of those in total because the other 6 are over here, and then the outputs from 4040, how they relate to whether they're multiplying or dividing. I've put a little table there that says how that works, and it's a dual rail power supply, minus 12 ground plus 12. Yeah, so when I actually put the thing together, the front panel looks like this. You've got the input, which is where your original oscillator signal goes in. Then you've got the output, which comes from the summing mixer, which has got combinations of all of these. These controls are basically volume controls for the various outputs. It's just kind of levels on the mixer stage. So you can actually increase how prominent each of the divisions or multiplications are within the overall signal. And that's it really. This is what the circuit board looks like, and you see it's a bit tight on the panel, which is why I thought I couldn't get the switch in. I might be able to get it in there, so I might come back and have another go at that. So there, yeah, there's the 3 chips and the other components, and then it's just lots of pots and a couple of jack sockets. This thing here, it's kind of a bit of a bus bar for the outputs, or sorry, bus bar for the inputs to the mixer section. So all the basically what's sold to the other side of these is the center tab of the pots via a 100k resistor. Look on this version, you can actually see I've got one each side. It was the easiest way of wiring all the pots together without having a ridiculous amount of wires or bits of component leads just twisted up all around the back of the panel. I decided that, yeah, I'd use just a couple of small strips of strip board as a kind of a bus for those. Don't forget you need to join both sides together if you use this method as well. Otherwise you don't get it all going into the mixer. And that's it really. So I suppose all to do now is go back and have a listen to what it actually sounds like. This is the 4046 shaper, actually in situ in Project 12. The way I've got it set up at the moment is I'm taking a square wave signal into the input. Now, one of the things was, when I was looking at the Barton Musical Circuits website, the demo on there said that it would accept any waveform, convert it through the comparator into a square wave that the binary counters and things would be CMOS friendly basically, and you would always get a square wave output. Well, I've tried it with a range of waveforms on Project 12 and I can only get it to work with square waves. So I don't know what's going on there. I may bottom that at some point in time, but for now I just feed it square waves and, well, you'll hear what comes out. So it's a square wave from It's my origami module. It won't work with I tried it with a triangle wave. I even put it through the buffered patch and it still wouldn't do it. So I'm using the square wave. Okay, this is the times 1. So all the other times and divides are all turned right down, so they won't be contributing to the output. And the times 1 is at about half volume, or yeah, 50% level. The trigger for origami is coming from the key step. You can't see it in this video image, but I play some notes on the key step. So there you go, some notes on the key step. And as I say, that is just, so it's a square wave and it's times 1. So essentially that's what you would get if I was just playing from the main VCO that's feeding the shaper. Okay, what we can do now is start and dial some of the other values in. So if I hold the key down there and start to bring in the divide by 2, divide by 4, bring divide by 8 in. Divide by 8 is basically just a rumble. If I turn all the others down, divide by 8 is a rumble. Divide 4, divide 2, you do sometimes, because it's just a very simple summing mixer, and there's sometimes a little bit of bleed through from some of the other channels that I've noticed. The other thing as well is that the output signal, I've got everything on the mixers all turned quite low because it's pretty hot. It's quite a high level signal. I can actually alter that on the circuit diagram, the output on the mixer. You can alter the gain of that with the feedback resistor. So I'm just I'll probably lower the value of that. It'll lower the gain of that output stage on the summing mixer. So I'll probably have a go at that and cool it down a little bit so it'll mix in better when I start using other things on Project 12. For now though, I'm going to bring in some of the multipliers. Times 2. Times 4. Times 8. Take some of the low ones out. So you can see I'm going to go. Some interesting things going on. So that is literally just, there's no effects dialed in or anything like that. It's just simply all the outputs. You can play for some real kind of almost horror movie type sounds out of it. So yeah, I'm gonna turn a few things down, and what we'll do, I've got a more complicated patch setup, in that I can now, I'm using my patch point changer, which again I don't think is actually on the computer screen, on the video screen. But I can switch patch point now. So what's going to happen now is the output is going to go through a diode ladder filter, and things are going to get triggered by envelopes. And one of the other things I'm going to do is I'm going to basically set a sequence going, if I can. Well, there you go. Just a bit of fun, really, just to show you some of the things it can do. I'm going to have hours of fun mixing and matching all these divides and multiplies and changing all the different timbres that I can get out of that. So, yeah, I think it's definitely a module that's going to get some reasonable amount of use in my various patches. So, yeah. Don't know about you, but I quite like that. There you go, the 4046 Wave Shaper. I really like the output from that thing. It really fattens up the synth sounds. I'll put a link down in the description for the Barton Musical Circuits website. I'll also put a link there to my Dropbox folder that'll have my stripboard layout in it. And, well, that's all you need. So, yeah, go on, have a go. Build your own.